Today's notes is on page 6 in our math notebook. I'd like you to write with me. My colors are purple and black. Today we're going to be talking about standard NS.4, and this is divisibility rules. Divisibility basically means if something is divisible, or can you divide a number by something. So let's write divisibility rules. A lot of I's in that word. And that'll be what we're working on. This is going to help us learn standard NS4, which is 3 different pieces: greatest common factor, least common multiple, and distributive property. You will need to know these rules to help you. So how do you know, change colors here, 2, for example, how do you know if a number can be evenly divided by 2? Well, normally the number ends with an even number. So the number ends with, this is my shorthand for with, W/ an even number. So I'm going to change colors here. What do I mean by that? If it's divisible by 2, put a box around 2. The examples might be like 22. It ends with a 2. 38 ends with an 8. Those are even numbers. How do you know if it could be divisible by 3 and 9? They have similar rules. So I'm going to put 3 and 9 together. 3 and 9. You're going to add the numbers, and then they have to be a multiple of 3 and 9. So here's how this works. You're going to add the numbers, and it has to be a multiple of 3 and 9. So what do I mean by adding the numbers and it has to be a multiple of 3 and 9? So for example, if I give you 18, the number is 18. If I add those together, you're adding a 1 plus 8, which equals 9. So you're looking at, is 9, is that a multiple of 3? Yep. 3, 6, 9. Is it also a multiple of 9? Yep. So this is a multiple of 3 and 9. They're both multiples. So if I try 15, for example, if I add those together, I'm adding the 1 plus 5, which equals 6. Now, is 6 a multiple of 3? Yes, but it is not a multiple of 9. So 6 is only, this one here, is only divisible by 3. And we kind of know that because 3 times 5 is 15, but 9 will not go into that. 27. You're going to add the digits together. 2 plus 7 equals 9. And 9 is one of those it's a multiple of both of these. So 3 and 9 go into 27. The next example I have is 5. How do you know when a number can be divided evenly by 5? The number has to end with a 5 or a 0. So the number ends with, there's my shorthand, W/ with 5 or 0. I'm going to change colors for my example in that one. So 5, box it in. Examples could be like 50. It ends with a 0. Or you could put like 9,995. Ends with the 5. So that will be evenly divisible by 5. There will be no remainder when you divide them. The next example is 6. How do you know if 6 goes into a number? It has to be an even number. And when you add the digits, it also has to be a multiple of 3. So it has to be an even number. And when you add the digits together, has to be a multiple of 3. So it has to be 2 things. It has to be an even number and a multiple of 3 once you've added those digits together. So let's give you some examples to try with 6. I'll move this up just a little bit. 36. So first off, you're looking to see it's an even number, so that's right. And what happens when you add 3 plus 6? 3 plus 6 equals 9, and 9 is a multiple of 3, so that's how you know 6 goes into it. So you're probably wondering, I went 3 and 9, 5, 6, I skipped 4. 4 and 8 are kind of similar, so I saved them for the last. 4, you have to add the last 2 place values. So you're going to add the last 2 place values. And when you add the last 2 place values, it has to be a multiple of 4. So semicolon, it has to be a multiple of 4. And I'm kind of squeezing that on here all in one line. It has to be a multiple of 4. If you need to go to the next line, that's fine. So the example for 4, you have to add the last 2 place values, and then it has to be a multiple of 4. So what do I mean by that? For example, if I give you the number 48, it only has 2 digits, so when you add 4 plus 8, that equals 12. N is 12. Yep, it's a multiple of 4. You could go 4, 8, 12. So that's how I know 48 is evenly divisible by 4. What if you give me a really, really large number? Doesn't matter what number you give me if the last 2 digits, when you add them together, is a multiple of 4. So for example, this was 48. What if I gave you the number 1,348? So again, with 4s, you're just adding the last 2 place values. The last 2 place values are the 48 again. So we already know 4 plus 8 equals 12. And that is a multiple of 4. So it's kind of a trick with the last 2 place values. The last example I have is 8. And 8 is similar to 4, but you're going to add the last 3 place values. And then it has to be a multiple of 8 instead of a 4. So you're going to add the last 3 place values, semicolon, and has to be a multiple of 8. So use my other color. We're going to box in 8. You're going to add the last 3 place values and it has to be a multiple of 8. So if I give you a really, really, really large number like 1,448, looking at the number here now, if I add the last 3 place values, I would have to add the 4, 4, and 8. So 4 plus 4 is 8, plus another 8 would give me 16. And is 16? Yep, it's a multiple of 8, so I would know that 8 would evenly divide into that. If you don't know if something evenly divides, you would just have to work it out and then see if it's going to have a remainder or not, but these divisibility rules are good to have and good to know. So you're going to draw a line in your notes right here after divisibility rules. And now we're going to talk about some terms that would be helpful to know if we're going to talk about greatest common factor and least common multiple. You at least need to know what factors and multiples are. This is going to probably be a review. Factors is the term. So I'm going to box in factors. I'll give you an example. If I say 2 times 4 equals 8, or if I said 1 times 8 equals 8. Could you circle the ones that are the factors? So you would be circling 2, 4, 1, and 8. So what are factors? Factors are the numbers we're multiplying to get an answer or to get a product. So you heard me say product. Yes, anytime you are multiplying, the answer to multiplication is called the product. So there's a term. Factors are the numbers we multiply to get that product. So factors are really just numbers, the number sign with an S, you multiply to get a product. So in this case, we were trying to get 8. Its factors are 1 and 8, 2 and 4. So if I ask you to put a star here, here's my directions. Find the factors of 81. Then I'm asking you what numbers can you multiply to get 81. So I always like to start with 1 because 1 times anything you can get it. So one of the factors would be 1. The other one would be 81, like 1 times 81. And I'm looking, does 2 go into 81? No, it's not even. So I'm using my divisibility. Does 3 go into 81? It does. 3 times 27 equals that. Does 4, if I add the last two place values together, is that a multiple of 4? No, because 8 by itself is a multiple of 4, so that wouldn't work. 5 doesn't work because it doesn't end with a 5 or a 0. 6 doesn't work because it's not an even number. 7 doesn't work, and we don't even have rules for 7. It's kind of an oddball number. And then 8 doesn't work, but 9 works. Actually, if you think about 9 times 9. So if I listed the factors, I don't need to list 9 twice. What are the factors of 81? They would be 1, 3, 9, 27, and 81. Those are numbers you can multiply to get 81. You've done this before, or you should have done this before. Another thing we're going to put in our notes is multiples. So multiples, I'm going to write that down. And again, I'd like to give you an example of multiples so that you can kind of come up with the term you want or the vocab for multiples. So if I give you 3, 6, 9, 12, 15, 18, comma, and that's going to go on forever. These are multiples of 3. So multiples is really just like skip counting by a number. And in this case, my number was 3. So I might give you directions that say, okay, well, multiples go on forever and ever and ever. So what if I just say, I'll put a star here for the directions, find the first 6 multiples of 4. And why am I just asking for the first 6? Well, it's going to go on forever. I don't want to list them forever, so they might just ask you to find that. So I'm going to put 6 blanks here. 3, 4, 5, 6. In other words, you always start with the number I'm asking in multiples, 4. And if you're skip counting by 4s, then you're going to have 8, 12, 16, 20, 24. And we are going to stop there for our notes for today on this page 6.